Greetings, students. This is Irvin Howard again. The next series of videos, we're going to talk about algebra. All right. Algebra will incorporate understanding various concepts or various math concepts, such as simplifying expressions, the distribution property, combining like terms, square roots, exponents. So these series of videos will focus on the algebra portion, and you've already experienced the pre-algebra portion from the last set of videos. So we're focusing on algebra. And to begin the series, we're going to talk about simplifying expressions. And simplifying expression basically focuses on two steps: reduce terms separately, cancel terms respectively. You want to look at both factors in the numerator and denominator when you're talking about simplifying expressions as a quotient or a fractional, algebraic fractional expression. Let me give you an example. We're going to simplifying fractions. All right. We have 22x over 11. All right. This is an algebraic expression. We have the denominator 22x, and then we have the numerator, 22x, and then we have the denominator 11. In reducing this fractional expression, again, reduce and cancel, all right, respectively. All right, just something simple for you all to remember. All right. So again, we find out what factors that we can identify in the numerator as well as the denominator, and we know that 2 times 11 represents 22 as factors, and we have 11 at the bottom or in the denominator. We cancel like factors. All right, we cancel out like factors or like terms when we're having a quotient, a fractional quotient. All right, so they cancel, so you have 2x left as your answer. All right, let's do another one. Adjust the camera. We have 12. I'll write the 12. All right. We have 12 times x plus 2 times y over 4 times x plus 2. All right. Just in simplistic matters, we see that you have x plus 2, or the factor of x plus 2 in the numerator, and then you have x plus 2 in the denominator. And also you have 12 and you have 4, all right, respectively. You want to reduce the factors, meaning what kind of factors are common in both numerators and denominators, and then you cancel them out. So since you have x plus 2, this parentheses represents a multiple, or its times. All right, this is a multiple times factor. So these two can cancel. All right, and then what factors in the 12 and the 4 that have in common? So you may say that 4 and 3 are in common, so you can cancel. I'm just going through the shortcut way. So you have 3 at the top, which is the leftover, and this is 1, because they both cancel. You have 4 times 3, which is this factor, and you know that the 4 cancels, and you have the 3 left over. And then your answer is 3 times y, because everything cancels. Now, everything cancel in the denominator means that the value becomes 1, not 0, because it's impossible to have 0 in the denominator, and at the same time as the identity, 1 times 1 is the identity of the value based upon your former fundamentals of math concept. So you have 3y as your answer. All right. let's try another one. I'm going to move down here the paper. All right. And then I'm going to write something very simple. 22 plus 2 over 16x. All right. This is simple too. Again, look at your factors in your numerator and denominator and see what operation you can perform. Now you can perform this simple operation 2 plus 2, which equals to 4 over 16x. Now you get to the heart of what this represents. This is an algebraic expression now. All right? All right? Now, this is an algebraic expression, but when we perform the operation, we have just the algebraic expression, and then this is the point where we want to reduce and cancel. All right, want to reduce and cancel. So we cancel. We find out what factors are in common with the 4 and 16, and you probably guess 16. The factors of 16 could be 4 times 4 or 8 times 2, but you want to find the factors that have the exact same factors common in the numerator and the denominator, and you can cancel out immediately. In this case, 4 times 4 x, okay? And then this 4 and that 4 cancels. So this becomes 1. All right, and then you have 1 over 4x. X is your algebraic expression that also is part of your denominator. So it did not cancel. So that's your remainder. All right. So your answer is 1/4 x or 1 over 4x, or all right, you can write it like that. All right. Now, sometimes, all right, this is your answer. All right, 1/4 x. All right. Now, in combining like terms, all right, I'm going to position this here. Combining like terms. All right. Now, in combining like terms, a term is an expression containing numerical coefficient that multiplies a variable such as x or y and raised to a certain power. So examples of terms or algebraic terms. You have 2x, all right, this is the coefficient, and this is the variable, all right. Okay, this is the variable x, y, it could be y, z, and so on. Coefficient, this is the numerical coefficient, the number that's in front of the variable, all right. Now, other variables may have exponents, so you can have 3x, which is the exponent or raised power. All right. You can have negative 4y squared. You can have 3x to the 0 power. All right, and when you have 3x to the 0 power, anything raised to 0 power that in the coefficient, the x is the variable raised to 0 power, so the variable becomes 1. All right, so that variable becomes 1 because anything raised to the 0 power is 1. So you raise this to the 0 power, and this equates to 1. 3 times 1 is 3. So when you have coefficients that do not have variables, they are represented as whatever the variable is raised to the power 0. All right, in a nutshell. All right. Let's combine some like terms in simple operations, just to give you some examples. 6x plus 3x. All right. In this sum of the x, the variables, the like terms are x and x. They have to be the exact same exponent or what we call degree in order to perform whatever the operation that we have. In this case, 6x plus 3x will equal to 9x. You perform the operation of the coefficient with the operand, or the operator, excuse me. You perform the operation by adding, in this case, the coefficients, and then you're writing the what? The x. All right, the x in this term is represented as the first power, or the first degree. All right, another example, 7x minus 4x equals to, in this case, you're taking the difference. This will be, take the operation, which is subtraction, 3x. All right. Now, if you have a term like this, x to square minus 4x squared. Again, they're of the same degree type. You can perform the operation. In this case, this would be 3x squared. Hello? Yeah. Where are you located? Oh, I thought you were in the classroom. You're in your office, right? Okay, sure. Okay.